Well, good evening. Welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here. Let me get out of this screen here and we'll get to our regular screen. It's great to have a nice crowd here, especially even on a cloudy night. But we'll talk a little bit about that a little bit more in a minute. So I always like to check to see who's here for the first time. All right, that side of the room. Okay, and who here are members? All right, got a handful. All right, very good, very good. Well, I always like to point out, especially for those people who are here for the first time, that the people who raise their hands second have a valuable piece of information. Kopernik belongs to what's called the ASTC, Association of Science and Technology Centers, and with a Kopernik card, you can get into 380 other science centers that honor our cards. So you could go to Roberson, you could go to the Corning Museum of Glass. Actually, I think there's somebody from the Corning Museum of Glass who has their membership there and came here tonight. So it works in both directions. And I just earlier this year, I was up in Montreal, and my wife and I went to the Montreal Science Center, and it basically, just for the two of us, for that one trip, cost us basically half of what a year's membership here is. I took my daughter down to the Franklin Institute in Philly, and they were even more expensive. In fact, it was, had I paid street price for myself and my daughter, it would have been more than the cost of a regular family membership. So if you like this kind of place, it's worth checking out. So we've been around for over 50 years as a public observatory, but also an informal STEM education facility. Earlier this week, we had school groups up from Shenango Forks doing some STEM engagement. We have got a couple more school groups coming in through the end of the year, end of the school year, that is. But we're now getting ready for our big summer camp. So if you go to our website, the website always tells you what's coming up. So obviously, we're highlighting our tonight's program, but we have a very extensive summer camp. This is the 34th year that we've offered STEM summer camps for students between actually rising second graders through high school. And actually, as of Sunday night, the early bird pricing ends. So if you know a child or a grandchild or a nephew or a niece that might enjoy a week-long day camp. It's a lot of hands-on work, and bottom line, it's just a lot of fun. I wish I had this when I was growing up here, and so definitely want to check that out. The other thing, we do other programs as well. Tomorrow actually is our Rocket Fest. This is a program where people sign up for launch windows and get a rocket kit. They've been building it over the past couple of weeks. Tomorrow, starting at 9 o'clock, people will start showing up with their rockets, and by the end of the day, we'll have launched over 150 rockets from here. Even if you didn't buy a rocket, if you want to check it out, feel free to just come on up and enjoy the launches. Trying to think here what else to point out here. Actually, for those that are here here on site, in the back there is just an extraordinary quilt that was made by the wife of one of our board members, and we are actually raffling that quilt off in September at our Astrofest. So their tickets are $5 a piece, or you can buy 5 tickets for $20, and you can get those tickets at the gift shop. But one of the things I really enjoy doing are these Friday night programs. It's an opportunity for us to really continue our education, especially some of the younger people that are in here. You'll notice there's people here with gray hair, which means that they have not stopped learning. And it's really, we're trying to sort of model that for you as well, in that it's an opportunity for us to really continue our education. I quite frankly wish I could live another 50 or 100 years just to see where technology has progressed. I mean, I remember watching Neil Armstrong walk on the moon, back in 1969. Back then I used to have to walk to the TV to change the channel. no longer. So what's going to happen over the next 25 or 50 or 100 years? And I think coming here, you said you can get a sense of where things may be headed. One of the other things that we do with these programs is we now live stream them on our YouTube channel. We now have over 14,000 subscribers. So tonight's program is being live streamed right now, and we literally have people watching from around the world. There's often a woman in Adelaide, Australia, who is watching, Lindsay. Right now she's finishing her breakfast in Australia, and as she's cleaning up, she's watching our programs. So you can actually go to our YouTube channel, and again, so you'll see tonight's program is up there right now. Last week we had a part 2 of a talk about virtual reality. In the past, we've had the Rocketry Club from Binghamton University come and talk about their work. But we've also had talks about ticks and tick-borne diseases, deep fakes and AI, talking about how fossils can really tell us more about the Earth's history. So there's a lot of good stuff on here, and what's great about it is that you can actually go back to these videos whenever. So we have the last 6 years worth of videos here. So, all right. So, one of the things that on our YouTube channel that we do promote is that we do these Friday nights, but also if there's some sort of a astronomical event or we've actually done a couple of like we actually had the launch in this case the return of the Artemis II watch party. Actually, it was very convenient because they landed at 8:07 on a Friday, so we got to watch the landing, and then we transitioned to the talk on deep fakes. But anyway, we also have done programs where we actually put cameras on our scopes and do things like watch a lunar eclipse. And so Jenny Carty, our live stream astronomer, created this 1-minute time lapse of the lunar eclipse that happened back in 2025, in March of 2025. Most of you probably didn't see it because it started at 2 in the morning. But you can sort of see how the penumbra starts to cover the moon. Then they change the exposure, so we start to see what light is being refracted through our atmosphere. Now we get to that final blood moon stage. It was just an extraordinarily clear night, and very fortunate to have Jenny stick around for that whole event. So all this can be found on our YouTube channel, and let me just turn that down a little bit. All right. So here we go. So again, we've been very fortunate to have speakers from local speakers from Binghamton University, people in the community, but we also have people that have zoomed in. We've had a mission controller from NASA talk about the work that he does in NASA Mission Control in Houston. And we've got a number of great talks lined up. I'm just about ready to announce what they are. Although next week we're actually going to do a program on the summer skies. So if you want to know what's coming up in the summer, come on back on next Friday, and by that point we'll also know what we've got lined up for the rest of the summer for Friday nights. But again, we're very fortunate to have the Southern Tier Robotics Club come back again. This has got to be the 8th or 9th time, at least. Every year they come up with the robot has a different requirement that it has to perform, or requirements that they have to perform. And as you can see, it's a non-trivial task to bring it up here, but we appreciate that. So I don't know if Andrew or Art, who's going to start this out, but we'll turn this over to you.
My name is Andrew Beck. I'm one of the mentors here for Southern Tier Robotics. We'll go through sort of the program structure, go through what this season robot is supposed to do, go through the competitions that we went to. We went to 3 competitions this year, and then we'll go through the impact that it has on the students and the community, and give you a demonstration of the robot. So we are Southern Tier Robotics, Team 2053, out of Vestal High School. We're a club there that works in the basement building this. We have tools and computers down there. So really what we do is associated with First Robotics. First Robotics is a program that provides life-changing robotics programs for youth to learn the skills that they need to go into their own careers. Next slide. So we compete as a team for First Robotics Competition, which is a yearly challenge that we get every January. The challenge is kept secret, revealed to us in January, and we have generally 8 weeks to build this 115-pound machine to achieve the goal and play the game every year. There are 3,700 high school teams that compete every year, and about 150 competitions events take place each season. Like I said, we went to 3 competitions. At 2 of those competitions, we competed against 40 to 60 teams, and then the 3rd competition, which we'll get into later, the World Championship, we competed against 600 teams. Like I said, they host a World Championship in Houston, and that is an invite-only competition that's held each year in Houston, Texas. So I'll turn it over to the students. You guys want to come up? Why don't we, Douglas, do you want to come up real quick? So I'll just have them say their names and grades real quick, and then we'll start with Liam doing, or Mason doing the CAD and design.
My name is Liam Delario. I'm a sophomore and a new member on the team this year.
My name is Mason McConnell. I am a senior on the team, and I am part of our CAD and design team. So we design the many parts of our robot for them to be machined.
I am Douglas McLaren. I am also on CAD and design, and I am in 9th grade.
My name is Alex Baumlin. I'm in 9th grade.
All right, so we're going to take a bit of time to go through each of the roles that we have on the team. Obviously, Mason just spoke on our CAD and design. They're in charge of 3D modeling and designing the robot, which those designs are then sent over to the manufacturing team, which I'm a part of. We are in charge of the making, machining, and assembly of all of the parts for the robot to get it to the state it is in now. Electrical, they do all the wiring, which I'm not too sure, but you could probably see some of it on the robot now. Right after that, programming will make the code that operates the robot for the autonomous period and the teleoperated period. Yeah, and then we have our media and outreach team, who simply just comes to competitions. They're in charge of spreading out information about our team, our social media, and other resources like that. Next slide. So for this year's game, we were assigned with taking fuel, which would be those little yellow balls over there, to score into the hub, which you can see on there, the big basket-looking thing. What else? Oh, yeah. You can't just point and say that, bro. Yeah, I messed up there, bro. Okay, so another, point of the robot's design is to be able to maneuver on the field around obstacles like the trench, which would be that little bar towards the, further side of the field, and the bump right next to it. Our robot, we designed to be able to go over to the bump and not fit into the trench, but, that's not too important. So we went to 3 competitions this year, the first of which was the Hudson Valley Regional in Suffern, New York. This event qualified us to go to Houston World Championships, as we placed 3rd out of the 48 teams there and placed 2nd in the finals of the event. We were allied for this match with Amped, a team from Taipei, and Flux Robotics, a team from Pelham, New York.
So the second competition that we went to was the Tech Valley Regional, which was in Albany, New York. And we ranked 20th at this competition, and we were still able to go to playoffs as the 8th Alliance, and we made it into round 3 of playoffs. And then, since we performed well enough at our first competition, we qualified to go to the championship in Houston. And the championship is, there's 8 fields, and each field is named after a certain scientist. So we were named after Marie Curie, and there are 600 teams at this competition, roughly 50,000 attendees, and we ranked 58th out of 74 in our division.
We'll just play a short video. It's 3 minutes, just from our competition in Curie division, just to give you a sense of what this robot does on the field. Moves a little bit faster on the field than it does here.
3, 2, 1, go!
The Sweet 16 underway for your match here on the Curie division. 3 Blue Alliance robots grabbing some fuel. 2 from the center of the field. 166 racing over to their human player station. Double swipes for the Blue Alliance. Red Alliance trying to make their way back. Fuel continuing to pop up and in on both sides. Red Alliance with a 3-point advantage. Blue Alliance, a little bit of cleanup work here to do, and they surpass that Red Alliance threshold during the transition period. 166 makes their way to the center of the field. Full hopper, full of fuel, making their way over the bump. Leap of faith, lining themselves up, shooting from a far distance in your blue zone. Some of the shots do go outside of the hub. And now long distance shots of your Red Alliance. Courtesy of the 8280 machine. Now the Red Alliance hub online.
The way this match works is...
Gray matter getting a little bit hung up on the neutral zone. Their partner is 7539. Elevate, freeing them up, getting them back into business, continuing to shuttle fuel over to their side of the field. Last volleys up and in for your Red Alliance from K90. And now the Blue Alliance is back online. Shots going a little bit too high on some of your Blue Alliance shots there, but they race back, more fuel into their neutral zone. Chop Chop going far, picking up in the Red Alliance. Straight shot over the bump they go.
I think we actually get stuck.
Now Pop Fly out of the Merrimack machine. 55 seconds left to go. Blue Alliance with a slight lead. Red Alliance coming back. 27-24 Avalanche under some defense from 166, who's just over there picking up their fuel, denying the Red Alliance stockpile. Race back to their side of the field. 20-53 getting stuck, but they do have fuel in their hopper, able to send some of that over to the waiting jaws of their partners of 27-24 and 8280 of K90 and Avalanche Robotics, respectfully. Under 30 seconds left to go. Both hubs active once again. Blue Alliance starting to come back, cutting down the deficit that the Red Alliance currently has over them. 300 points over for your Red Alliance. Blue Alliance down by about 70. Last volleys for your Red Alliance going up and in. Gray matter playing some defense. Last 3 seconds left to go. Blue Alliance slowly closing in, but was it enough as time expired?
And we do end up winning that match. I included this slide real quick just to give you a sense of how big this event is. These are 8 fields all lined up in a row. This is actually from last year's game, but you can see 8 fields lined up in a row, sort of end to end, and it's a huge venue.
These are just a few of the awards and accomplishments we've made as a team so far. Obviously, this is not all of them, but these are just some of the trophies we have in the shop at the moment. So if you look right over here, we have the plaques for our finalist and quality award from the Hudson Valley Regional. We were awarded the quality award due to the quality of the build of our robot and how good our construction was. Over here, we have the winner trophies for the Robot Rumble event from last year's season, as well as another quality award from that season. These are just some items from champs, like the team plaque thing we were given. I don't know what to call it, but impact. Now, First Robotics has a lot of community impact, especially on members of teams, as it allows students to get experience in STEM fields such as tech, engineering, manufacturing, and programming. Obviously, you can build relationships with mentors that can provide a lot of experience from industry professionals from a lot of the fields associated with STEM. But first, on top of that, gives you opportunities for networking to build a resume or just public speaking, communication experience and things like that. But colleges are where First really does have an impact, because a lot of colleges in the engineering field will tend to look for First alumni when it comes to recruiting processes, as well as offering $30 million in scholarships.
We are headquartered, out of Vestal High School, but we have, mentors and students. Students come from the Vestal High School, but the mentors themselves are, like I and Andrew, are volunteers, and most of us come from engineering backgrounds, and that's a lot of what we bring to the program, that we actually help and work with the students. And a lot of it is based upon, a lot of the effort that we put in is based upon our engineering backgrounds. And we're always looking for help, other volunteers, from the parents, and even if you don't have students in the school themselves, like Andrew and I are, we don't have students in the high school, but we do volunteer our time. And we actually enjoy it. It's really a lot of fun for us. And a lot of the other volunteers have gone through this type of a program and have found it so enjoyable that they basically continue on as volunteers. Also, we do have, obviously, the high school students as a club, and we have students anywhere from 9th grade to 12th grade. And so people like Mason are be graduating, but we're eagerly awaiting the 8th grade students, the currently 8th grade students, that will be graduating into 9th grade. And we'll be teaching them the basics of robotics, and as they go through the course, from 9th through 12th, they'll gain more and more experience. And I think I want to reiterate, I think it was Liam who said that this program is really good experience and training, especially if the students want to continue on into a STEM program. But I would also add that that's not necessarily something that, if they want to go into something else, the humanities or biology or any kind of other sciences. One of the things that this program really provides the students is experience in working in teams, working on problems where there is no answer in the back of the book, and something that gives them a little bit more of experience that they're gonna, the real world experience that they're gonna get into as they go through their career into college and then on into whatever career that they wish. So if now at this point in time, the program is for the Vestal High School students. So if you have any of your students are interested, you can have them come up and talk to me or Andrew, or we have the email down there, which is Southern Tier Robotics at gmail.com. You can email that, and we will get back with you. Okay? Okay, kind of to wrap this thing up, we have a lot of sponsors. We cannot, running this program is pretty expensive. There is money to create the robot there, which is runs into thousands of dollars. And also we do our trips, the regional trips, and into Houston. And the transportation, the hotel, registration fees are very expensive. And it's critical that we actually go to these things. For one reason is that it actually exposes the students to other teams, seeing what the other teams do, so they get a much wider view of what robotics and really what engineering is and what teamwork is. So that's critically important. And then when we go, it's actually fun. You know, it gets them excited. It is something that we can look forward to. So, you know, we start in the first week in January, and we run really hard. We basically have meetings 3 or 4 days a week after school to get this pretty complex robot built and tested. And all that efforts, actually watching it compete is really the kind of the cherry on the cake. It makes it it's a lot of fun, and they also get to meet other people also. So it's important that they build the robot, but it's also important that they go to these competitions and actually see, you know, what the robot can do that they've built. And in order to fund that, we have many sponsors from the local area, as you can see here. You know, NYSIG, the IEEE, BAE, and Corning, and the Williams Auto Group. So if you're planning to buy a car, you know, please go there and let them know that we told you to go there. That would be nice. And I also really want to give a shout out to the Vestal School District. They have really supported us with obviously the facilities, but they've really also supported us with funding for in order for us to go to competitions, and that is not a small amount of money. It's quite a substantial commitment that they've made to us, and we are really grateful to them. And without them, we could not have made this happen. Okay?
So we'll go in here to our demonstration of the robot. Got a couple of QR codes on the screen if you wanted to scan them, one for our Instagram, one for our website. I'll pass around this fuel. This is the game piece, just so you can have a look at it and feel it for yourself. But yeah, we'll go into that. I don't know if you can hear me. So I'll sort of explain what's going on here if you can hear me. Do you want to stop real quick, Mason? So, as you can see, we're attempting to shoot into the hub. We were making some changes after our competition at Champs, so it's not entirely consistent right now, but something we're working on for future. So, how this works, I guess you can see it picks up the balls using the intake, feeds them through the spindexer into the kicker, and out through the shooter. So what this actually has for a drive base is a swerve module. And if you want to demonstrate just like a figure eight or something to demonstrate how that works. So as he's driving, straight is always that way. So if he pushes the controller straight forward that way, it always goes that way, no matter which orientation the robot is facing. Makes it really easy. It's almost like a video game to control this thing. Easy to determine which way to point the joystick. It can also turn on its axis if you want to just turn it like that. Yep, it can just do a normal turn like that, and then it can, the other thing that this has, what you might notice is these QR codes right here on the hub. It's actually using these, we call them April tags, and it's using a camera right here to detect exactly where it is relative to that hub. So it knows exactly where it is on the field. Yeah. Anything else you wanted to add? Cool. If you want to disable it real quick, we'll take questions.
Okay, so it seems to me like there's obviously elements of this that are being like directly controlled by the operator, but then you're saying that there's it's using the QR codes to kind of orient itself. So, like, what's the relationship between what this thing is doing autonomously and what this thing is like, and the person who's controlling it?
You want to answer that, Mason?
Okay. We're fine.
So I control it. I control its movements fully, but there's a button on the controller that I can press, and if it sees any of the tags that are on the hub, it will automatically spin to face the direction that it needs to. And it will adjust the RPM of the shooter wheels for the distance that it is from the hub as well.
Is that the decision on how the speed done automatically or done by the pilot?
It is done automatically.
So
The pilot does have some preset ones they can do, though, for if they're trying to pass or something. But if you want to shoot, it does do it automatically for you.
And the purpose of the QR codes?
The robot has a camera on it that can see them, and there's a little onboard computer that runs a bunch of calculations and will orient the robot for the direction that it needs to be to shoot at.
So if you were off angle, it would be able to compensate for that?
Yes, it would.
Any questions? Yeah.
Can these QR codes and or the basket end up being at varying heights, so it will auto-calculate based on that, or is it just assumed to be a fixed height?
No, they're always the same height. You've got to hear it.
Yeah, they're always the same height. So this is a set goal for this competition, and if we raised it up or lowered it, the robot wouldn't really know what to do, and it would most likely miss.
Question in the back?
So if he decides to face another direction, does the robot start moving the direction he's facing if he pushes the button forward?
No. So I can be facing any direction and still be able to move forwards when I push the stick forwards.
What are you using as your yaw reference? Like, how do you know which way is forward?
From when the robot starts, usually there's a station on the end of the field, and you set the robot to face away from you, and whenever you turn it on, it just knows that that's the direction that you consider as forwards. And there is a button that I can use to reset it if it gets off somehow.
So are you using dead reckoning to keep track, like with a gyroscope to keep track of your orientation after that?
It does have a gyroscope on it that keeps track of position, orientation, and whether or not it's level, which it shouldn't not be, but you know.
This is on the word should.
Yeah.
If it can't see an April tag, it will automatically adjust and use dead reckoning to determine exactly where it is, assuming the wheels are on the ground.
Are the QR codes also on in the actual competition, or is this?
So he asked if the QR codes are on the hub during the actual competitions, and they are. Yes, they're on almost every field element in the competition, and you can use them however you want to use them. For us, we use them for aligning the robot to score.
Any other questions?
What's the field of view of the camera?
We can adjust it, but right now we have it as 70 degrees.
Again, I've seen you guys have been. This team has been up here, many probably for the past decade. Every year the challenge keeps changing. In the past, there was a opportunity for people to actually raise the robot off the ground, and can maybe you talk about did yours do that, and if not, why not?
So this year you could put a climber on your robot because there was a hook on the field, and if you climbed on it and got your robot entirely off the ground, you would get points. Except we decided that this wouldn't be worth it because in the time that it would take us to climb, we could just score it more than that amount of points normally. So we figured that it would just be a waste of time and inefficient.
So basically, you did the math. Yeah. Good. Another question?
Yeah, so I'm just curious too. Like, so it seems like with regard to the actual like lobbing mechanism on this robot, right? You've got like a circular platter that seems to feed it into like this little chute that kind of like shoots it. I'm kind of curious, like with regard to like this robot versus the other robots that other teams like constructed, like how similar did the like lobbing mechanisms end up being versus like were there like a bunch of different solutions to the same problem?
So actually this year there were like a lot of different solutions that people had. This is what we call a fixed shooter, where it's just a tower that shoots in one direction. And that was pretty common, but there were also turrets where the top of the tower can rotate and face in any direction. And also what are referred to as dumpers, where instead of having like one little tower, it's one really wide tower that can just shoot a ton of balls at once. And those were probably the best kind of shooter for this season.
Sometimes these competitions, things break, and I'm wondering, did you have that experience, and how did you deal with it?
So this season we didn't actually have too many issues with the robot breaking during matches, and we have a pit crew of like 3 to 4 students who between matches will check the robot to make sure nothing is broken, and if something is broken they'll try to fix it or at least make it not a problem anymore as fast as possible so it's ready for the next match.
A few more questions here. How was your team organized? And not everybody did everything, I take it. So could you talk about, it seemed like the team picture, you had the better part of 15 to 20 students or so. They talk about how that was organized and how that played out.
So during our competitions, the team is organized into separate groups with varying tasks at the event. We have pit team, which this guy here, Douglas, was on. They're in charge of repairing the robot and preparing it between matches. And then we have our drive team, who's in charge of the control of the robot and playing in the matches. this guy's on that. Then we have our scouting and our media teams. Our scouting teams are in charge of watching matches throughout the event and collecting data on other teams and our own robot in order to help us form alliances later in the competitions with other teams, depending on how we place. Media, as explained earlier, they just take a lot of photos and stuff, I guess.
Any other questions from the? Here, I'm gonna walk this over here.
I'm very interested in the scoring process and how much it's just a matter of kicking points in, or how much of it is in terms of evaluating the overall, if you will, skill or abilities that are shown in creating the robot.
So for actual matches, it's usually just points to, or whichever alliance scored more points wins. But outside of matches, there's judges who they will talk to every team that's there, and usually they'll be talking to you for like 10 minutes, and it's their job to talk about the stuff that like isn't just scoring points. So how you impact the community or the students, or like your manufacturing processes and your like the organization of your team. And there are awards for that as well, not just winning.
Is there a certain rule as to how much the mentors can do versus what the students can do?
No. There are some teams that are primarily student driven, where the students do like everything. And then there are some that are mostly run by mentors who are just teaching students what to do. We like to have a good balance of both so that the students can get help if they need it, but they're also learning in the process.
All right. And how much, from year to year, how much of the stuff that the motors, the controllers and all that, how much can you reuse from year to year, or is it you got to start from scratch?
So motors and other normal standard components can be reused from year to year. But custom parts, like the panels on the side of our shooter or the big polycarb plates that make up the sides of our robot, we wouldn't be able to use those. We're not allowed to.
All right. And I take it there's a size limitation?
There is. This year it was without the bumpers, which are the blue fabric bumpers on the side of the robot. It was 30 by 30. And 30 inches tall. And this one is like 29 and a half inches tall. So.
Excellent. Any other questions here in the audience? Oh, I went back here.
I would just like to know the origin of the name of the robot, just to see if I'm correct about
it. Is Parks and Recreation.
Okay, going old school, I guess, right? All right, so I have a couple of questions. Again, this is a subset of your team. I apologize, I had to step out earlier on, but could you introduce yourselves, what you did, what was your main focus of the, in this organization, and what grade you're in now, and if you're a senior, what happens next?
I'll start. My name is Mason McConnell. I'm a senior, and I'm going to college next year for electrical and computer engineering.
And where?
What?
Where are you going?
SUNY Polytechnic Institute.
Okay, up in Albany.
Yeah, but outside Utica.
Oh, okay, right.
My name is Alex Momlin, and I in 9th grade, and manufacturing.
You're part of the manufacturing team.
Yeah.
All right. All right.
I'm Liam Delario. I am a sophomore on the team, and I'm a part of the manufacturing team as well. As I previously mentioned earlier, our job is to construct and assemble the parts of the robot in our build season, and yeah, that's pretty much what we do.
Okay.
I am Douglas McLaren. I'm in 9th grade, and I'm on the CAD and design team. We design everything and then send it off to manufacturing to be built.
So how much were you able to actually build yourself as far as like milling machines and that kind of stuff, or did you have to send it out and had commercial entities do that for you?
We actually were given a ton of money by the school, the high school, to buy some CNC machines for our shop. And we have then that allows us to make almost every part of the robot ourselves, which is, it saves time because you don't have to like wait for them to ship it or make other things, and also money because you don't have to pay them to make it for you.
Is there just to loop back again to the parameters of the robot? Is there a weight limitation?
There is. The weight limitation, it changes every year, but this year it's usually around 120 pounds. This year it was 115. And this robot weighs 114.8.
Just coincidentally, right?
Yeah.
Excellent. Well, it's funny because I'm looking at some of the structure in here, and I mean I would imagine some of the a good portion of this is aluminum, but that I could see you sort of like cut out a bunch of material that if you don't need it, why don't need it? Why add that weight?
Yeah.
So excellent. Unless there's any other questions, if the team wants to sort of stay here, have people come on up and take a look. We'll have to ask our astronomy people. Could you tell me if there's any, Willa or Lucia, can you tell me if there's anything to see outside? Ask one of the KES guys if there's anything to see outside, or Willa. I mean, I'm sorry, or Bryn. We have a rule here that if you don't get an opportunity to actually do any viewing through the scopes, if you paid to get in, you get a card to come back on another night that hopefully would be clear, and would love to have you look through our telescopes. By the way, this weekend is a blue moon, and for those that don't know what a blue moon, the moon will not be blue, but the blue moon is a term that they use for when you've got two full moons in the same month. We had one on May 1st, and we're going to have one on Saturday, actually technically Sunday morning, on the 31st. And, we've got, it's all right, it's clear. So you don't get the free card. You got to go out. And, all right, yeah.
I'd like to just kind of have them shoot. No, I'm just interested in having them shoot so I can take a picture.
Oh, okay, here we go.
Yeah, so if you guys want to come up, and ask a few questions, take a look at the robot a little bit closer, you can. We'll turn it off so it's safe to touch and everything, and but yeah.
All right, so thanks again to the team for coming up, and the mentors for making this happen. Again, for those who are here for the first time, to get to the scopes, you go through the lobby. There's another set of double doors. Go outside there, take a left, and I believe the moon will be up pretty soon. But also, we should be able to see potentially Jupiter and maybe some satellites. All right, so next week it's summer skies. So come and learn what to expect this summer in the night sky. Thanks again.